So hello friends, welcome back to my channel. Let's start the next part of this video. The smallest sieve size according to Indian standard is 0.045 mm. Okay. According to Indian standards, in a 2 mm sieve, there are two holes. Each sieve is circular and its diameter is 2 mm. Each hole is a square and its side is 2 mm. There are two holes per centimeter length of the mesh. So the correct answer is each hole is a square and its side is 2 mm. Okay, it's not circular, it's square in nature. Sieving is not practicable for grain sizes smaller than about 0.075 mm. Okay, 75 micron পৰা তলত গলে আমি sieving to basically use নকৰো, it's not practicable. Okay, the effective size of soil is D10. Yes, D10 is called effective size of soil. The uniformity coefficient of soil is defined as the ratio of D60 to D10. Yes, Cu is equal to, we know that Cu is equal to D60 by D10. Yes, so it will go here. Next, question number 86. The particle size range is measured by effective size, curvature coefficient, uniformity coefficient, and none of this. So particle size range is measured by effective size. Okay, particle size range is measured by effective size. Am I right? No, right? Because particle size is not measured by effective size, but it is measured by uniformity coefficient. Okay, the particle size range is measured by uniformity coefficient, that is Cu, that is D60 by D10. Yes, so the next question is, a soil having particles of nearly the same size is known as uniform soil, poor soil, well graded soil, coarse soil. Okay, so it is called uniform soil. A soil having uniformity coefficient more than 10 is called uniform soil, poor soil, well graded soil, coarse soil. It is well graded soil. Uniformity coefficient if it is more than 10, it is called well graded soil. Okay, we know that when Cu is greater than 4, it is called well graded gravel, and when it is greater than 6, it is called well graded sand. Okay, remember these points. Next question, uniformity coefficient for a uniformly graded soil is nearly unity. Uniformity coefficient for a uniformly graded soil is nearly unity. This is true. Next question, Stokes law is applicable to particles up to dash effective diameter, 0.0002 mm effective diameter. Okay, sieve analysis is done if all particles do not pass through square opening of 0.05 mm. It is correct or incorrect? The question is correct. For gradation, we do sieve analysis above soil of size 0.075 mm. The next question is, the ratio of unconfined compressive strength of undisturbed soil to the unconfined compressive soil strength of soil in a remolded state is called sensitivity. Yes, it is called sensitivity. We know that St is equal to Qu undisturbed by Qu remolded. Okay, next question number 93. The property of a soil which enables to regain its strength on remolding in a short time without change of moisture content is called thixotrophy. Yes. Next question is data based. The unconfined compressive strength of a very soft clay is about very less, yes, 10 to 25 kilonewton per meter square. The unconfined compressive strength of a hard clay is above 400 kilonewton per meter square. Okay, remember this. The sensitivity of a normal clay is about, the sensitivity of a normal clay is about 2 to 4. Okay, remember this table. If sensitivity is 1, it is called insensitive. If sensitivity is 2 to 4, it is called normal sensitive. If sensitivity is 4 to 8, it is called sensitive. If sensitivity is 8 to 16, it is called very sensitive or extra sensitive. If sensitivity is greater than equal to 16, it is called unstable or quick clay. Okay, remember this. So, our next question, the maximum water content of a saturated soil at which the reduction in its moisture does not cause a decrease in volume of the soil, it is the shrinkage limit. If you reduce the molecule, if you reduce the moisture content, if you reduce the moisture content at one point, the volume remains the same. If you reduce the moisture content at one point, the volume remains the same. The volume does not change even if you reduce or decrease the water content. This point is called shrinkage limit. Okay, this point is called shrinkage limit. In somewhere between you will get plastic limit, and after that you will get liquid limit. Okay, next point, next question, when water content in a soil is reduced beyond shrinkage limit, the soil will be in a solid state. Yes, it is very simple. The water content in a soil at which just shear strength develops is called, the water content in a soil at which just the shear strength develops, it is called liquid limit. Yes, the plastic limit of a soil is defined as the plastic limit of a soil is defined as the minimum water content which makes the soil to be rolled in a 3 mm diameter thread. Yes. Next question, the consistency index, that is IC. IC is WL minus W by WL minus WP, or you can say WL minus W by WL minus WP, or we can say that WL minus W by IP. Yes. So, question number 101 will be WL minus W by IP. WL minus WP, this is called plasticity index or IP. The next question, the consistency index is also known as relative consistency. Yes, it is true. The liquidity index, that is IL. IL is W minus WP by IP. Yes, W minus WP by IP. So, the correct answer will be D. Yes, 103, it is D. When the consistency index is 0, then the soil is at its liquid limit. Yes, when the consistency index is 0, the soil is at its liquid limit. The soil is in a semi-solid state if the consistency is more than unity. Yes, if the consistency is more than unity, it is in a semi-solid state. A soil with consistency equal to 1 at its is at its dash limit. A soil with consistency equal to 1 is at its A liquid limit, B plastic limit. So, it is plastic limit. Yes, a soil with consistency 0 is liquid limit. A soil with consistency index at 1 is in its plastic limit. Toughness index, that is IT. IT is equal to IP by IF, that is plasticity index by flow index. Yes, plasticity index by flow index, plasticity index by flow index. Number 108, a sample of soil has liquid limit 45%, liquid limit is 45%, plastic limit is 25%, shrinkage limit is 17%, and moisture content is 30%. Moisture content is 30%. The consistency index of the soil is, so we have to solve this, the consistency index of the soil. Yes, we know IC is equal to WL minus W by WL minus WP. Put the values here and find the values and write down in the comment below what is the answer. Okay. I want answer from every one of you of question number 108. The shear strength of a soil in the plastic limit, the next question is the shear strength of a soil in the plastic limit is dash than that in the liquid limit. Of course it will be higher. Yes. Next, the liquid limit exists in sandy soil, gravel soil, silty soil, clays. The liquid limit exists in clays. Okay. The plastic limit exists in sandy soil, gravel soil, silty soil, clays. Plastic limit also exists in clays. The liquid limit minus plastic limit is the plasticity index. Yes, liquid limit minus plastic limit is the plasticity index. When the plastic limit is greater, equal or greater than liquid limit, then the plasticity index is 0. We consider it as 0. If the WP is more than WL, we consider this as 0. Okay, plasticity index we consider as 0, not negative. Okay, the shrinkage index is liquid limit minus shrinkage limit. Yes, liquid limit minus shrinkage limit is the shrinkage index. The flow index in soil indicates the flow index in soil indicates the shear strength. Yes, is there a, yes, option number D, it indicates the shear strength variation with water content. Okay, next question is the moisture contents of a clay soil is gradually decreased from a large value. The correct sequence of the occurrence of the limit will be, okay, the moisture content is gradually decreased from a large value. This is volume, this is water content. Yes, so moisture content is decreased, so this is will be liquid limit, this will be plastic limit, and this will be shrinkage limit. Yes, so at first will be liquid limit, then will come plastic limit, then will come shrinkage limit. So option will be A. Yes, the next question, the clays which exhibit high activity contain montmorillonite, have high plasticity index, both A and B, none of this. So the answer will be both A and B. That is, the clays that exhibit high activity will contain montmorillonite, will have high plasticity index. Okay, the activity of clay is defined as the ratio of activity of clay is defined as the ratio of IP by percentage of fraction of soil which is less than 2 micron, that is percentage of clay fraction. Okay, so the answer will be option C. Yes, plasticity index to clay fraction. Okay, also remember, if activity of soil is less than 0.75, it is called inactive. Okay, If it is between 0.75 to 1.25, it is normal active, and if it is greater than 1.25, it is very active. Okay, or you can say it is active soil. Okay, next, let's come to the next question. The plasticity index is the ratio of liquidity index and flow index. Of course, this is wrong. It is the difference between liquid limit and plastic limit. Yes. Okay, last question for today, that is match the following. Soil transported by water, we know it is as alluvial soil. Soil transported by wind, aeolian soil. Smallest ship size 0.045. Maximum size of particles of clay, that is 2 micron. Yes. Okay, so see you in the next video. Okay, thank you.